So here you can see in Traceability Studio, among others, traceability module between two doors documents containing requirements. The first one is representing the requirements for the top level system, while the second one is just showing up the requirements for one of the subsystems. There are 122 requirements in the top document and only 19 in the child document, and there are no traces among these elements. So let me show you the traceability panel, both source and target, and there are no traces. Of course, I could create traces manually in here just by clicking the source and the target and establishing the link. But let me show you how the semantic capabilities included in Traceability Studio can generate new traces. So first of all, for this module, I have identified three different types of traces, and there are a number of semantic algorithms to suggest you new traces. So let me start with the flow down type of traces. Normally, you will find requirements at the top level that directly will flow down without any change into the child documents. So in order to find this, you just check the configuration of the semantic engine, and in the suggested traces evaluation, I just decide to find only those requirements that are fully the same between the source and the target. So I change the level of similarity that I request to 100%, right? So you click OK, and then you just execute the semantic search engine. It's important to mention the tool now has identified two different possible traces. So let me show you both source and targeting here. You can notice that in some cases it is not that the tool is just evaluating the full text and representing those requirements that are equally the same. You can include even some minor changes, like in here I'm using should, and in here I am using shall, but this is not a meaningful difference. So this is why the tool is considering these two as fully equivalent. Remember the use of synonyms, the use of different modal verbs. So all this is implemented in the tool, right? And in here I am speaking about the temperature warrior, which is the name of the full the top level system, while in here I'm speaking about the same action or the same constraint in this case, but in this case it is for the control system, which is a child in the PBS. So Traceability Studio can connect to modeling tools like Cameo or Capella to retrieve the structural information of your system, the product breakdown structure in this case, so that we can also combine not only the linguistic information within the both source and target, but also the information from the model, right? So even if the subject of this requirement is different to the subject of this one, but this is a child in the PBS, so this is why the tool is considering these two requirements as fully equivalent, considering these two different levels of abstraction, right? So this was just one possible algorithm. Let me show you some other algorithms, like for instance the allocation of physical properties, right? So I now change and pick allocation in here, and there are some in addition to these two options, there are some others that come out of the box, and you can even create your own custom tasks to identify new traces. But out of the box you will find these 6 custom possible options, including this allocation algorithm, right? So you just run the algorithm. Some of the algorithms, like this one, will require some parameters. In this case, as I said, I'm aiming to evaluate or to find requirements speaking about properties. Properties are part of my thesaurus, are part of my dictionary, and all the properties are included in a cluster, in a group of concepts that I call other properties in here, right? So I selected the cluster other properties, and I want to identify items that are only at one level of difference between the parent and the child. There has to be only one level in the PBS. So I must provide the tool with the parameter of the PBS. And now the tool has identified two possible candidates to trace, right? So this 2-1. In this one, the source is speaking about the weight, physical property of the temperature warrior, the top level system that shall be 50 kilo. While in the target, I'm speaking about the weight of the control system, and in this case it is 450 grams, right? So it is not an issue that I'm speaking about kilograms here, grams there. In here I have written first the property and then the system. In here it is the system first and then the property. It is not an issue. The semantic representation is exactly the same. So this is why the tool has identified this one, and also, by the way, this other one, which both source and target are speaking about the maximum power consumption. In this case, it is the power consumption of the top level system, the temperature warrior. One in here is the power consumption of the control system, which is the system of interest for this other document, right? So, of course, for every single trace, you can either accept the suggestion or discard the suggestion, or just close, and you can accept or discard all of them in a block, right? So one other algorithm, let's say for derivation of requirements, could be I want to identify those requirements in the left, speaking about actions within a specific state, and here in the target the same state, right? So this is one more algorithm here, where as a parameter you just establish a pattern. For those of you who still don't know about patterns, please refer to our website. So this is a pattern representing what is the condition for my requirement, where the condition is expressed in a specific mode. And of course the second parameter is the cluster, the name of the state. So for those requirements where both source and target are meeting the same pattern and representing the same state, right? They will be considered as a candidate for linking, right? So I click just on OK, and after a couple of seconds, then you have two more suggestions. In this case, the derivation. You can open the trace, and you can find that both source and target are speaking about actions for the different systems, the temperature warrior in one case and the control system in the other case, but both are in ready mode, which is one of the possible modes of both systems, the top level and this particular child, right? So this is why the tool is considering these as candidates for traces. And then, of course, we have plenty of other algorithms, but just let me show you other means of finding derivation, which is just applying a semantic algorithm, semantic proximity between both source and target. But now I'm not requiring both to be fully equivalent. I just reduce a little bit the threshold so that other similar requirement but not fully equivalent will appear just by clicking here in a matter of a couple of seconds. Then I have more suggestions. Now this derivation, you can see that the level of similarity is not 100%, but it is always above 70. That was the limit that I expressed, right? So we could go in detail and decide whether or not each of those requirements, if you want to keep these possible traces.